Hi, welcome to our next junior relations video. We're going to talk about gradient now. The gradient of a line is a number that determines how steep the line is. The larger the number, the steeper the line. Now, the gradient is remembered as this little fraction, rise over run. The rise represents how much it moves up and down, and the run represents how much it moves sideways, left or right. Now, please do not get confused with coordinates. Remember, coordinates, we always go x first and then y second. When we talk about gradient, we always do rise on the top of the fraction, rises up and down, and run on the bottom of the fraction, which is sideways. Okay, let's get into example 1 and try and explain gradient a bit better for you. This line has a gradient of 3/5. Now, what I'm going to do is pick 2 points on the graph, and you can see that I've had to rise up 3 squares and run across 5 squares. Rise up 3, run across 5. Now, it didn't matter which 2 points I chose to pick. I could have picked 2 points down here. I still would have rise 3 squares, run 5. All right, what about the second example? This line has a gradient of 1/8. Again, let me just pick 2 points on the graph, make sure they're on the grid and on the line, and you can see clearly that it rises up 1 square and runs along 8 squares. Okay, now I've just drawn these two graphs, the same two we've just talked about in example 1 and example 2 here on the same grid. So the top one has a gradient of 1/8 that rises up 1 and runs along 8, and the bottom line has a gradient of 3/5. It rises up 3 and runs along 5. So let me just quickly convert each of them to a decimal. 3/5 is equivalent to 0.6 and 1/8 is equivalent to 0.125. Remember, we go top number divide by bottom number to turn them into decimals. Now you can see the 3/5 fraction is bigger. Now we just spoke a few slides ago that the larger the number of the gradient is, the steeper the line is. So because 3/5 is bigger than 1/8, we can see that the gradient of 3/5 is steeper. And it does look steeper. It's going uphill at a bigger, sharper rate. I'd rather walk up a gradient of 1/8 if I wasn't that fit than I would of a gradient of 3/5. All right, here's example 3. This line has a gradient of 3. Now this ain't a fraction, this is a whole number, 3. So we need to turn it into a fraction by writing it as 3/1, because 3 divided by 1 is still 3. So now let's pick 2 points on the grid and see how it rises up 3 squares and runs along 1 square. So when we have whole numbers, we must write it as over 1, right? Anytime you see a gradient that's a whole number, you write the gradient as a fraction over 1. For example, 9 is equivalent to 9/1, a rise of 9 and a run of 1. All right, let's look at this tricky one. Example 4. This line has a gradient of 1.5. Oh, now we've got decimals. Well, first of all, let's write it as 1.5 over 1. So we've got rise over run. But I don't like decimals. That means rising up 1.5 squares, and it's quite messy to guess where 1.5 squares. So here's a clever trick. If you double 1.5, you get 3. If you double 1, you get 2. So 1.5 is equivalent to the fraction of 3/2. So now that's much easier to understand. This graph, this line rises up 3 squares and runs over 2 squares. All right, draw a line with a gradient of 5. Well, if I'm asked to do that, I start anywhere on my grid. Remember, I'm going to write it as 5/1, so I start anywhere on my grid, and now I just need to go up 5 squares and across 1, because 5 is 5/1. All right, one quick thing to finish off with. Please just be aware of the following. If we have a gradient of 2/3, which rises up 2 and runs along 3, the same line could have a gradient of 6/9 if I pick different points, up 6 and across 9. And that's because 2/3 is the same fraction as 6/9. So just because you get 2/3 and your mate gets 6/9, you're both correct, okay? All right, well, that's the first video down on gradient. Thank you very much for watching.